All right. Formula for standard deviation for proportions. Sigma of p hat equals square root of p times 1 minus p over n. This is one of the formulas that's on your yellow sheet. And it is labeled, but you have to know when to use it. What condition has to be met that lets me use that formula? 10% condition. Do we meet the 10% condition? Yes. You would need to show some work to justify that. So I have to see that 50 is less than or equal to 1/10 of all Hershey's Kisses. I certainly think that there's more than 500 Hershey's Kisses in the world. So that condition is met. I'm allowed to use the formula. This, by the way, is condition number 2. When it says check conditions, I need to check, was it randomly selected? Are we independent? That's what allows me to use that formula for standard deviation. That's why my 10% condition is important. Are we independent? So the problem with using this formula here, as opposed to last semester when we knew what the true proportion was, I don't know what the true proportion is here. So what could I use to estimate the true proportion? P hat. Whatever your point estimate was, that's what you are going to use to calculate the standard deviation. So for mine, I had 0.26 times 1 minus 0.26 over 50 and then square root the whole thing. If you did not have this formula on your page, you need to calculate this for your point estimate. Because I'm using p hat and not p, we actually call this the standard error of p hat. Instead of standard deviation, we call it standard error, which is abbreviated SE p hat. So the standard error is calculated exactly the same as the standard deviation, but you're using your point estimate for p instead of the actual value for p because we don't know that. I'm going to pop all this up just a little bit higher on the screen. So far, I've hit on 2 conditions that have to be checked. Who can tell me what the 2 conditions are that we've already talked about? Random sample, 10% condition, or independence. What we're after is independence. The 10% condition is what allows me to assume independence. Would it be okay, would it be appropriate to use a normal distribution to model the sampling distribution of p hat? Yes. Using what? Why am I allowed to use normal distribution? Large counts. N times p, or in this case I would have to do n times p hat, because I don't know p, has to be greater than or equal to 10. N times 1 minus p, which I have to do as n minus, or n times 1 minus p hat, is greater than or equal to 10. So I checked both of mine. From the numbers that I was hearing for point estimates around the room, my guess is that everybody's is going to come out that a normal distribution is appropriate here. You want to calculate this for your point estimate, not for my point estimate. So if your point estimate was 0.4, you're going to have 50 times 0.4 and 50 times 0.6. My point estimate was 0.26. If you had a point estimate of 0.24, 0.32, whatever your point estimate was, that's what you should be using here for your large counts. Right. Yes. What if they're both? If one of them is not greater than 10, then we cannot use a normal distribution. A normal distribution would not be appropriate, and we would either have to find some other way of modeling this, or we just can't move forward. Do you think it ever happens that n times p or n times 1 minus p comes out to be less than 10? Yeah, absolutely. Definitely possible. It's even possible if you have a large sample. Because if your p or p hat is like 0.01, it's possible that you would end up with a large count that is under 10. Thank you. Maya, we are just now flipping to page 8, so you'll need to catch up on the other pieces. All right. Flip it over to page 8. Let's see who remembers their empirical rule. Do you guys remember empirical rule? That is our bell curve, yes. It's not the only bell curve, but it happens to be a bell curve. In a normal distribution, 95% of the data lies within how many standard deviations of the mean? 2. This is the 68, 95, 99.7 rule. So it's approximately 2 standard deviations. It's close enough that that's what we say. It's actually a little bit less, but when we're learning the empirical rule, we just kind of let that wash over us. This value is called the critical value. Super important. How many standard deviations are we away from the mean? Critical value. If you guys have your graphing calculators with you, go ahead and pull those out. If you do not have a graphing calculator with you today, we'll let you know. That you guys are going to have to share. Okay. They take batteries. They need AAA batteries. All right, so we are going to use inverse normal on your calculators. You guys remember how to get to inverse normal? Second bars, and it's option number 3. So we're going to use inverse normal on the calculator to determine what is the critical value, how many standard deviations are we away from the mean for 80% of our data. So I got to figure out what to type into the calculator. So I drew a picture first. Always draw pictures first. If I want 80% of the data, what does that lie between? So the bump in the middle here. How much is in my tails if 80% is in the middle? 10 in each. So if I were going to try to figure out what this cutoff point is right here, how much data lies to the left of this upper bound? 90% of the data. 10% of the data lies below it. 90% of the data lies below the upper bound. So what I'm going to type into my calculator is inverse norm, and then inside parentheses, we're going to put 0.90, and then hit enter. That's it. What'd you get? 1.282 if you take it out to 3 places, or 1.28. Curious. What about if I'd asked about the lower bound? What happens if you do inverse norm of 10%, 0.10? Pop that in your calculator. Negative 1.282. Remember, we're talking about an equal distance on either side of the mean. So if I am 1.282 standard deviations away over here, I should also be 1.282 standard deviations over here on the left. That's why one of them is a positive, one of them is a negative. So that would be my critical value for 80%. How would I need to change this to do 90%? What would I do differently to calculate a 90%? How would that impact the tails? If I have 90% in the middle, how big are each of the tails? 5%. Each of my tails would be 5%. So I could do inverse normal of 0.05. It's going to give me a negative number. I just want to know what's the distance. So I would just change it to a positive. It's the same if I'm on the upper boundary or on the lower boundary. So inverse normal of 0.05 or inverse normal of 0.95. Those should give you the exact same thing. What are you getting? And we're going to write down the critical value. No, you're absolutely right. If you do 0.05, you get negative 1.645. Yep, so the critical value is 1.645 or 1.65. What would my tails be for a 95% confidence interval? No. Look here. When I had 80% in the middle, that 20% that was left over had to be split between my two tails. When I have 90% in the middle, that remaining 10% has to be split evenly between the two tails. So if I have 95% in the middle, how much is evenly split between my two tails? Each of those would be 2.5. So how could we calculate the critical value for a 95% confidence interval? Yep, inverse normal, 0.025, yes.
So, because for like the 80 one,
Mm-hmm.
why did you just take the 90 away?
That's, I was finding how many standard deviations away from the mean this end was. This end over here is exactly the same number of standard deviations away, but to the left. That's why it's a negative. Yep, you don't have to do both tails because they're going to come out the same. You can do just one of them. If you do the one on the left, so you took whatever the leftover percent is and you cut it in half. So for 95%, this tail over here just has 2.5 because the other tail also has 2.5. Then I'm going to get a negative number when I do inverse normal. But that's just telling me that it's that many standard deviations away on the left. And I want to know how many standard deviations away are we on either side. It's going to be the same number either direction. If you get a negative, it's just saying you found the one that was on the left-hand side. It'd be the same distance away on the right-hand side. What is this critical value? 1.96 is absolutely correct. What about for a 99% confidence interval? How much is in each of my tails? 0.05%. 0.5% gets split between those two tails, so 0.005. Giving us a critical value of what? $2.576.
So we had a way to find the thing we put in the inverse norm, just subtracted by the percentage divided by 2.
That is the exact formula for this, yes. You walked right into it. A shortcut way to find these critical values is you do 1 minus whatever your percentage is, that gives you the tail amount, and then cut that in half because it's split between the two tails. So you're going to do inverse normal of 1 minus percent, cut in half, divided by 2. Does that make sense? Calculator is going to give you a negative back. That's just telling you that you found how far away it was on the left. Change your critical value to a positive always. All right. Last bit. I want you guys to calculate your margin of error. Margin of error. So you're going to take your critical value and you're going to multiply it by your standard deviation. Critical value times the standard error of p hat. We're going to finish the rest of this up tomorrow, but you need to have what your standard error is. Or sorry, what your margin of error, not your standard error. You need to have what your margin of error is so that when you walk in tomorrow, you can do the next piece of it. Yeah, so 1.96 should be the same on everybody's page, but your standard error of p hat will be unique to you and your partner. Have a great rest of your day, guys. I will see you again tomorrow.